Good morning, dear students. Welcome back again with the new session and new lesson of Standard 8, Chapter 7 Metals and Non-Metals. In the previous lesson, we have already classified the matter into element, compounds, and mixtures. And now we are going to study about metals and non-metals in details. So, as as per the whole lesson is listed into a small points so that you can easily understand. I request you that while going through this video, please be ready with your textbook. The first point is matter can be classified as elements, compounds, and the mixtures, which you already studied. All elements are categorized into three general types, that are metals, nonmetals, and metalloids. Metalloids are those elements which possess the property of both atom as well as metal as well as non-metals. They are called as metalloids. Physical state of metals are ordinary. Temperature is usually solid. Mercury and gallium are exceptional because these metals are liquid state at room temperature. Then fifth point, all metals have characteristic metallic shine called metallic luster. So all the metals are lustrous. They have a special shining property. Most metals are hard. Sodium and potassium are exception as very soft and can be cut into pieces using an ordinary knife. All metal can be drawn into wires. This property of metal is known as ductility. So we say that all the metals are ductile. Ductile implies they can be drawn into thin wires. All metals can be beaten into sheets. This property is known as malleability. So we may say that all metals are malleable. Malleable means metal can be drawn into thin sheets. That is point number 8. Now point number 9. Metals are good conductors of heat. Silver, aluminum, and copper are the best conductors of heat. Metals are also good conductor of electricity. However, lead is an exception as it is neither a good conductor of heat nor that of electricity. Here, good conductor of heat implies heat can be transferred through the substances. Like all metals transfer heat from one point to another, whereas non-metal does not transfer heat from one place to another. Whereas in case there is one exception called as lead, which is neither a good conductor of heat nor it is a good conductor of electricity. Densities of metals are typically high. However, lithium, sodium, and potassium are exceptions as the densities are lower than that of water, and therefore they generally float on the surface of water. Most metals have high melting point and boiling points. Mercury and gallium are exception as these are liquid at room temperature. Although sodium and potassium are solid at room temperature, these melt at slight heating. All metal produce characteristic metallic sound with his sound when hit with a hard object. This property of metal is called sonority. Like for example, bell. When you ring the bell, मंदिर में घंटी होता है, घंटी बजाएंगे तो कैसे साउंड आता है? दैट इज कॉल्ड सोनरस साउंड. स्कूल में रिसेस होता है या फिर स्कूल छूटता है तो आवाज़ आता है ना, दैट साउंड इज कॉल्ड एज सोनरस. दैट इज ओनली प्रोसेस्ड बाय द मेटल. Contrary to metals which are either solid or liquid, non-metals may exist as solid, liquid, or gas. Carbon, sulfur, and phosphorus are solids. Bromine is liquid, and hydrogen, oxygen, and nitrogen are gases. Non-metals are generally non-lustrous, means no shining. However, diamond and iodine crystals are exception. They possess a great shining property, though they are non-metals. Non-metals can be colorless or may have different colors. Some gases such as oxygen nitrogen and hydrogen are colorless. Graphite is black, sulfur is yellow, and bromine is brown. Nonmetals are generally soft and brittle. Solid nonmetals break into pieces when hammered. Diamond is an exception and is the hardest known material, though it is a nonmetal. Nonmetals are neither ductile nor malleable. Neither they can be converted into thin wires nor they can be drawn into thin sheets. Nonmetals are bad conductor of heat and electricity. Neither they can transfer heat nor electricity through them. Therefore, they are bad conductor of heat and electricity. Nonmetals are light and have low densities. For example, oxygen, nitrogen, etc. have very low density. Nonmetals have low melting point and boiling points. Some solid nonmetals such as carbon and boron are exception as they have high melting points. Some elements have properties which are intermediate between metals and nonmetals. So these fall under separate category called metalloids. Some examples of metalloids are arsenic, silicon, germanium and antimony. Majority of metals have similar chemical properties because most metals have up to 3 electrons in the outermost shell. Metals lose electrons in their valency shells during chemical reaction to form positively charged ions which are called cations. For example, sodium donates 1 electrons, acquires positive charge. So before donating, sodium was having the electronic configuration as 281, but after donating, atom has converted into ions and the outermost, or you can say the electronic configuration becomes 28. Metals react with oxygen to produce metal oxides. Metal oxides are basic in nature and cannot react with acid to form and can react with acids to form salt and water. Metal plus oxygen gives metal oxides. Then it is basic in nature, react with acid to form salt and water. Generally, metal react with dilute acid to produce metal salts and liberate hydrogen gas. Now, point number 27. Some reactive metals react with water at room temperature to produce metal hydride with liberation of hydrogen gas. Examples of such metals are sodium and potassium. Magnesium does not react with water at room temperature but reacts with steam. Majority of nonmetals have 4 to 7 electrons in the valence shell. Nonmetals accept electrons in the valence shell to form negatively charged called anions during the chemical reaction. For example, chlorine accepts 1 electron. Chlorine is an atom with electronic configuration 2, 8, 7. Accept 1 electron converts into chloride anion and the electronic configuration is 2, 8, 8. Nonmetals react with oxygen to form the respective oxides. For example, carbon plus oxygen gives carbon dioxide. Oxides of nonmetals are acidic in nature, reacts with bases to form respective soluble salts and water. These oxides react with water to form an acid. Unlike metals, nonmetals do not react with dilute acids. Now prepare the list of uses of metals and non-metals in our everyday life. With some example here, gold is used in ornaments, gold medals. Silver in ornaments, medicines and silver medals. Platinum again is used in ornaments. Copper, alloy, electrical wire, etc. Aluminium, cooking utensils, cans, foils. Zinc in coating of iron to prevent corrosion. Nickel is used in making coins and batteries. Sodium is used in sodium lamp, table salt. Mercury is used in thermometer. Lead is used in car batteries. The uses of non-metals. Carbon in ornaments in the form of diamond and allotrope of carbon. In pencil, lead, that is graphite, and allotrope of carbon. And in fuel, it is used as a coal, kodsha. Oxygen it is used in breathing to support life. Chlorine in the purification of water. Sulfur is used in firework, patakadi jalane mein. Phosphorus again it is used in firework and fertilizers. Then iodine, it is used in medicines. Now, apart from the uses of metals and non-metals, there are certain elements which does not react with any of these elements. They are rare gas or noble gas. Now, some metals are found in elemental state in nature. Example of such metals are gold, silver, platinum, rhodium, palladium. These metals are called as noble metals. These metals are widely used in ornaments, medicines, electronic devices, and as catalyst. Now, what is catalyst? Catalysts are those substances which, though in the presence does not react with the does not react in the chemical reaction, but by just their presence increases the rate of chemical reaction. Such substances are called as catalyst. Like for example, for the preparation of ghee, nickel is being used, though nickel does not participate in any of the chemical reaction. Now, these metals are widely used as medicines. Sorry, we have completed it. Now, point number three, the purity of gold is measured in carat. 24 carat refers to 100% pure gold. Pure gold is very soft and therefore some other element is mixed so that it becomes little bit hard. Pure gold is soft and not suitable for making ornaments. So copper or silver is mixed with gold to make 22 carat gold, which is usually used as to make ornaments. Metals react slowly with some gases and moisture in the air and get degraded over a period of time. Slow process of degradation of metal is called corrosion. Reddish deposits on iron on rusting is corrosion of iron. हिंदी में बोलते हैं जंग लगना. Other examples of corrosion are the greenish deposits on copper and blackish deposit on silver. Now, copper, when you kept exposed to air for a longer time, greenish color is formed and a blackish color is found on the silver. Silver ornaments are there. If you keep it exposed to the air for a longer time, it turns into black in color. Especially with the hydrogen sulfide, it turns black immediately. Now, other examples of corrosion, no, sorry, paints. Now, what steps should be taken in order to avoid the corrosion? So, paint, grease, varnish, or oil is applied on the metal surface to prevent its contact with the air and minimize the corrosion. Application of coat of zinc on the iron objects is another method to prevent the corrosion of iron. Alloy is a homogeneous mixture of two or more metals or metals and non-metals. Alloys typically have some desirable qualities which the constituent elements do not have. For example, stainless steel is an alloy of iron with carbon, chromium, and nickel, which is corrosion resistant. And therefore, steel carries long lasting because it is an alloy of these elements. Cheap stainless steel objects develop vertical cracks if copper is used instead of nickel while preparing the alloy. The iron of Qutub Minar in Delhi is made up of an alloy of iron with small proportions of carbon, silicon, and phosphorus. The pillar is resistant from corrosion and lustrous till now, though it is prepared 1500 years ago. So, if it is an alloy, it is long lasting. So, here we have covered up all the topic of this lessons. When we start with the next lesson, till then, have a great day.